Okay, so let's now set up the offset of our instances. I'm just going to come and turn off our light display here. Seems to have turned back on here. Let's go back to our main setup here. So just go to our object context, to our setup. Before we do this, I just want to point out one thing here. You can see at the moment we've got all these little green stopwatches all the way to the end of our setup here. This is a time dependency we've got going on. They're not always bad, but you can see if we come to the end here, if we were to come to our geometry spreadsheet and say, let's look at our instance file attribute. This is where we're setting our instance. If we drag around our timeline, you can see it's a little bit slow and unresponsive here. It's not too bad, but the problem is we are currently bringing in animation every frame, and so that's changing, and then we're having to recalculate our attribute from pieces every frame. We're having to recalculate all this stuff all the way to the end. Now, as I say, it's not too slow, but it could be a little bit faster. And if you do have bigger scenes, sometimes this can become really slow. So it's always a good idea to keep an eye on things like this. Now, in the case of this, we are setting attribute from pieces based on our geometry. But we no longer really need this geometry to be animated because we are setting our animation to come now from the instances, which we've set up with a frame number here. So it actually is irrelevant if this is animated or not. Even if this geometry is just a still piece of geometry, it's still going to give the information of our variant, which will then allow us to calculate our attribute from pieces correctly. Instead of having to recalculate every frame, let's just come here after we've merged this, and let's just Alt drag to create a knot, drag over these two to create a line like this. We're going to put down a time shift node. And time shift is going to allow us to freeze our geometry. You can do a lot of things with time shift. It's super helpful. I'm just going to Control Shift to click on it. I'm going to set it to maybe frame 140. Can be any frame, but as long as we've now set this to a single frame, we're now essentially freezing our geometry here at this frame. And now you can see that our stopwatch has disappeared from this, and it's also indeed disappeared from all these as well. So now all this stuff is only having to be calculated once. In fact, if we come to the end, we look at our instance file again, you can see it's still updating here, but it's much faster. Now, in fact, our instance file itself does introduce another one of these time dependencies because we are setting our frame, which is changing each frame. So it is actually changing again now, and we have one here. But this isn't that bad. It was a little bit slow up here. We were having to calculate our attribute from pieces. So we've removed it from that, and I'm not too worried about this. The important thing is we now have a nice fast interface again. So let's now move on and set up our attribute along our branch. So we're going to come up to our top of our scene here, back to the beginning where we first imported our geometry. Let's take all of this up to where we added our normal. So we've got file cache, normal. Let's just move this up to make a bit of space. Now we're going to create an attribute that runs along here all the way to the end, and then we're going to use this to drive the frame number of our Redshift proxies. And to do this, we're going to actually create an attribute here by just going to turn off hide other objects. I've got both of these displaying at the same time. But yeah, let's create an attribute by using what's called distance along geometry. And we have used this before. And we can essentially set a start point. And this is going to create a distance attribute on our geometry based on each point's neighbors. Essentially creates a fall off for us, but it's better than just say a linear fall off, as it respects your geometry and will sort of flow around the edges. This isn't maybe the best example here because this is already fairly linear, but say you had a piece of geometry that was curving all around the place, like in sort of little spirals and stuff. The distance along geometry would create a fall off that would flow nicely around that geometry, and it wouldn't cross over between areas that were disconnected. So this is really nice for setting up this kind of effect. So let's start by creating a start group of points that we want to start our fall off from. I'm just going to put down a group SOP here. Let's call this start points. It's going to be a point group. Let's disable the base group and just enable by bounding region. I'm going to set this to be a sphere. I'm just going to middle mouse click on this to bring up our ladder and just drag down to about 0.2, somewhere like that. So we've got a nice small region to select here. Now with our handle tool selected over here, let's just move this up. I'm just going to maybe move this over to the start of where our camera is looking. I think this little patch of points here is perfect. So I'm just going to arrange this just to select a really small region on the end here. And this will be our start group. So on our distance along geometry now, let's set our start points to be start points. And you can already see there, if I control, middle mouse click, and just click on our distance to enable this, we now have a visualizer. And it goes from sort of blue here, it's not too easy to see, but it's blue around this area, to red at the end. And this is now our distance attribute. If we look on our points, we can see that's there. So we can come all the way down to the end of our setup now, maybe down to our color. Let's have a look at this. And in fact, if I just control middle mouse click again and just toggle that one, you can see that we now have this attribute stored on these points. And it's a little bit easier to see now. So these blue ones will be where we start from, and the red ones will be where we end. If we come to our geometry spreadsheet, let's look up our distance attribute. So let's just type dist. This is actually just like an actual distance. So it's going from a value of 0 all the way to about 1.22 or near enough. And the points that are 0 are, as you might have guessed, our start points. In fact, we could put down a blast node here to delete every point. Just to demonstrate this, let's just say points. Let's use our also groups function here by putting attribute dist equals 0. And then let's just delete non-selected. And you can see that's our start points there. And in fact, if you set this to be distance is less than 0.2, you can see we've got a little bit more there. And if we increase this, you can see it's slowly growing out along our geometry. And this is the kind of idea that we're going to be using to create this offset. So let's just delete this for now. I do want to remap this though. So rather than having a distance of 0 to 1.22, let's just put a quick attribute remap here. And let's remap our distance from 0 to 1.22 to 0 to 1. And now we've got a nice remapped value that goes from 0 to almost 1. Okay, so let's pull this down a bit further. I'm going to delete our attribute create here. We're not going to use that anymore. So at the moment, our instance file is set by just setting our frame to be attribute frame, which is our inbuilt frame in Houdini. Let's create an actual attribute now that we can use to control this. So I'm going to put down a point wrangle. And I'm going to create I attribute fr for frame. It's an integer because it's a whole number. It's a frame like 68, 75. So just an integer is fine. Let's make that equal to channel integer. So we're going to create an integer slider here. Let's just call this frame. If we create that, we can now drive our frame by this. But let's just set this again back to attribute frame. We can also use this here, and this will now evaluate to our current frame number. Now let's also put in a control to add an offset to this. So let's say I attribute fr plus equals, and let's do channel integer again, and let's just create an offset control. So with this, let's just name this as well, set frame attrib. If we look in our geo spreadsheet at our, let's just look at our frame number. You can see if I enable our control here by clicking on this, that we've got an offset here. So at the moment it's 72, but we can quite easily just add to this, say 10, and now we're at frame 82. This is going to be a nice easy way just to slide our animation around on our scene if we need to. Now the other thing that's important to know is we could increase this to a massive number, and now we're up to frame 216. But we only ever animated frames 1 to 150. So we're going to want to make sure that we're clamping this value to 1 to 150, because if we have a frame of 216, Redshift's not going to be able to find a Redshift proxy file for that frame number. So we're just going to clamp this, and we can just do I attribute fr. We're going to use the clamp function, and to use this you just take a value. You need an integer minimum, integer maximum. In the case of our integer attribute here, we use I attribute fr, so our self, and we're going to go 1 to 150. So now we can't go above 150, and if we go negative, we can't go less than 1. So that's quite nice and set up now. And the weird thing to sort of try and see about this is it's very hard to visualize this now in terms of like an offset. We haven't created the offset, but we're going to do that next. Now, when we were using copy to points, it was quite easy because we could just animate along here and you could see our plants growing. But all we have here is points. So we're going to create a quick visualizer that's going to help us see essentially what our frame is doing, just to make it a little bit easier to control really. Let's put down another attribute remap. And we're going to remap our frame attribute. We're going to remap this to p-scale. Now our frame we've just set to be between 1 to 150, which was our animation range. So let's put 1 to 150. And I'm going to remap this to p-scale to go between 0 and 1. Let's next create a cube. Let's bring this down to a small number, about 0.02 I think. Let's just drag our z-axis out so it's a nice long oblong going from the origin near enough along our z-axis. And let's just do a copy to points on this. Let's connect these up. Going to pack an instance. And this is just going to give us a little display of what our sort of current growth is. Now, it's important to know that this is currently showing p-scale and it's scaling up our little boxes here. But what we really want to think of this is just essentially a visualizer of where we are in our animation. So where our scale is 0, this would be frame 1 of our animation. So all our plants are curled up. And if we go all the way to the end where it's all big, this will be the end of our animation. So it should make this a little bit easier to see as we're messing around with these values here. Okay, so let's now actually create our offset for our thing here. So we have our distance attribute that runs from 0 to 1 along our curve. We can simply type I attribute fr. And we're going to do minus equals, so we're going to subtract from our current frame, let's say float attribute distance, which was our distance attribute. And let's just multiply this with a channel integer slider, and we'll call this offset delay or something like that. Let's create that. And also this is creating an integer. So I'm just going to convert this into a this is creating a float. I'm going to convert this into an integer just to be correct. If we put the floor function down here, it's essentially going to chop off the decimal point and just return the whole number. So if you have, say, 2.3, floor will just give you 2. If you had 5.8, floor will give you 5. So with this enabled and our offset delay, we can now increase this. And as we increase this offset, you can see we're now creating this nice sort of fall off to our animation here now. Just like so. I'm going to make this about 80, I think, for the moment. And again, it's important to remember this isn't going to scale our points. We're just using this as a sort of visual aid to see what our frame number is. This is just really representing the frame of our Redshift proxy. So I hope that makes sense. Let's also just add a little bit of random noise to our distance here, which will in turn add a little bit of randomness to our offset amount. So we're going to put down a attribute adjust float. Let's change the attribute name to be distance, or dist even. That was our distance attribute. We're going to adjust it with noise, and we are going to maybe add to this, and let's just use middle and range length. So that's going to add a value of 0, but you're going to be able to go as much as +1 and -1 in both directions. So I'm just going to bring this down a little bit more to about 0.25 maybe, I think. And let's just bring our noise pattern element size down. I'm going to middle mouse click to select our ladder. Just bring this way down. You can see we're adding quite a bit of fine detail noise in there. Let's say about 0.12. So now, if we were to view this, we can see this is essentially what our growth is going to be.